Hey guys, in this video we're going to be looking at how we can use trigonometry to do something called solving right triangles. So looking at the triangle that we see here with an angle measure of 11 degrees and a side length of 15 centimeters, how can we find this unknown length? So knowing already our trigonometric functions, the ratios, we want to begin by identifying the side lengths with respect to our reference angle. So we have our hypotenuse, knowing that the hypotenuse and the adjacent are the two that form the angle, and then our opposite is the one that's remaining. So if I desire to find this unknown length, the hypotenuse, we examine which sides we have. So we do not have the adjacent, so we're utilizing the opposite and the hypotenuse. So out of our trig ratios, the one that uses the opposite and the hypotenuse is the sine ratio. So we would say that the sine of 11 degrees, that value will equal the opposite divided by the hypotenuse, our unknown. So we have an equation that we can solve. So I'm going to share with you two ways of solving this this problem. They're essentially doing the same thing, but depending on how we want to think about this, one approach might be easier to understand than the other. Okay. So the first way of thinking of this is, let me write this down, sine of 11 degrees is just like an algebra equation where I'm dividing by x, so I need to multiply both sides by that value. Again, the idea of multiplying by x is so that I can remove our fraction. So I'll leave us with x multiplied by sine of 11 degrees. And we've seen in previous lessons that sine of 11 degrees is a decimal value. So we have now a numeric value being multiplied by x. So to isolate x, we would divide by sine of 11. And we would have 15 divided by sine of 11 degrees, which, when we compute this, is approximately 78.6126. Units would be centimeters. Okay? And as we become more and more familiar with using trigonometry to do this, we can essentially jump from this initial step. Most often we can jump from here down to this last step, knowing that when x is in the denominator, that we end up dividing. Denominator dividing. So another way of solving this problem is actually viewing this, our original, as a proportion. So sine of 11 degrees equals 15 over x. So any number, any value, I can always place over 1. So I've made this a proportion where we can cross multiply. 15 times 1, we know is 15. And we divide by the value on the outside, so sine of 11. So 15 times 1 is 15, divided by sine of 11. And we're getting exactly what we saw here, and that should make sense. We're essentially doing the same thing. So once again, when we compute this, we get 78.6126 centimeters. All right, so we're not always going to be using sine. It depends on what we're given in our diagram. We're not always going to be dividing at the end. It depends on where our unknown value is located within our ratio. But essentially, this single problem can be used to help us solve others. So let's go on and talk about something called what it means to solve. So when we say to solve a triangle, to solve a right triangle, what does that mean? So what it means for us is that we determine the remaining values. Those values would be, you know, the angle measures and side lengths. For the given right triangle. Okay, so one difference compared to what we just did is we, in the previous example, only had to find one value. Here, when we say to solve, we're finding every component of the triangle. So let's say that our triangle is 57 degrees and 24 millimeters. All right, so to make it easier for us to talk about this triangle, let's go ahead and throw labels on our vertices. Let's make it easier for us to talk about it. It's really going to be easiest to find our third angle first. So we know through the properties of a triangle that the three have to total to 180. So taking the two that we have away, we can quickly find the measure of angle C, which we will get 23 degrees. All right. There are other ways of finding the angle, like we also know that if we have a right triangle, the two acute angles have to total to 90. So you could have just right away taken 57 from 90 and gotten the same result. Okay. So what about the measure of side length AB and the side length from A to C? So we're finding both of these lengths. When it comes to solving, that's actually what we're doing here, solve triangle ABC. We can pick either one. It does not matter. Which we find first. So, AB, let's find AB first. So AB, we have the hypotenuse in our diagram. According to our 57 degrees, AB would be our adjacent. So we have adjacent hypotenuse that I'm pretty sure is cosine. So cosine of 57 degrees will equal the adjacent, which is our unknown, divided by the hypotenuse. All right, so solving this, as you've seen earlier, there's two ways of solving this. I like the fact that I can just multiply by 24. Being that 24 is in our denominator, I can just multiply by 24 to remove it, and x has been solved. So we see here that x is approximately, or AB I should say, AB is approximately 13.0713 millimeters. Okay? So then we found the measure of AB. So looking back, we have every angle measure. We have two side lengths now. And once we have a second side length, we have to find the third, obviously. We have two options, actually, two options to find this third. All right, so the two options are, first, I have two sides of a right triangle, so we can use the Pythagorean theorem to find the third. So that would be c² equals a squared plus b squared. We have our hypotenuse is 24. And then, let's see, 13.0713 squared, and then AC squared. That's our unknown length. So when doing this, we know we're going to have to subtract this value to the left, but we have to square each. So when we square the 24 and we square the 13.0713 and subtract the 2, we find that we get 405.1411. So again, we square and then subtract. And that, again, I had to round, so that's approximately AC squared. So when we square root both sides, we find that we get 20.1281 in units of millimeters. And that's the length of AC. So when we look at this second option, understand that we should be getting the same thing. So our second option, when we use trig to find our first length, we can actually use a trig ratio to find our last leg. So now we were looking for the adjacent, now we're looking for the opposite. So opposite hypotenuse, that would be sine. So sine of 57 equals, we'll use y, since we've already used x, 24. So like before, 24 is in our denominator, so we can quickly multiply both sides by 24. To isolate y, we find that when we multiply 24 times sine of 57, knowing we're in degrees, we get 20.1281. And look at that, we got the same thing, which, no surprise. Okay. So a couple of things before we end here. If you're using a trigonometric function, be sure that your calculator is in the correct mode. So if your angle measures are in radians, make sure you're in radians. If you're in degrees, make sure you're in degrees here. Otherwise, it's going to give us values that obviously are not correct. So we now know how to find unknown lengths on the right triangle and how to do this concept of solving a right triangle and what it means.